Let's start with the basic list operations. You can remember it. It will help you a lot because in Python we are having different kind of methods, built-in functions as well as operations. So all of these confuse us. So for getting rid of this confusion, we can remember it. First, um, first the mutability. Lists are mutable. Second, second is our concatenation. We can do concatenation in lists. Third is merging. Fourth is mutable, concatenation, merging, and then we have conversion. I'll explain all of them. Mutable, concatenation, merging, conversion, and then we have aliasing or shallow copying. Okay, and six aliasing. Alias, yeah, so yeah. Okay, then we have our cloning, or deep copying. Seventh, we have searching. Eighth, we have identity. Ninth, ninth we have empty, and on 10th, we have in 10th we have comparison. Okay, let's understand them one by one. What's mutability? Mutability means we can change the data items. We can change the data items of a list. A string is not mutable because we can't change the data items of a string. A string is a collection of characters, so we can't change the characters of any string. I'm giving you an example. Okay, yeah. Suppose like it's Sham. Fine. We can do indexing. There is no issue in indexing. We can print it like from if we want 1 to 4. Let's see what will be the output. 0, 1, 2, 3, 4. But 4 minus 1, 3. So it will print HYA. 1, 2, and 3. You can see HYA. Okay. It means our string is a sequence data type. But can we do our mutability in the string? Like we can change the character of a string. Let's try. Suppose if we are storing on the third means 0, 1, 2, 3 on the place of A. We are storing B. Let's see what will be the output. See, we can't do. Why we can't do? String object doesn't support item assignment. Item assignment means changing the data items. That's why string is what? A string is a immutable data type. Fine. Now I explain why our list is a mutable data type. We have 3 and we have 6. We have Rita and we have 4.5. Yeah, this fine. Let's try. Let's try to change this Rita. It's on index 2 with what? Kavita. Print. Let's print them. Okay. Let's see what will be the output. See, it has changed with Kavita. Rita has changed with Kavita. That's why we say lists are mutable. I hope you understood it well. Okay. Next operation is on list we perform is concatenation. Let's try whether our list support concatenation or not. Suppose we have a list as 1 comma 2 comma 3. We have another object that's list 1, and in list 1 we try to do the concatenation of list with 4 comma 5. Let's try what will be our output with it. List 1. See, 1 2 3 4 and 5 are concatenated. Concatenated means ending the data items at the end of the list, and here it is our result. It means list support concatenation. It proved. Again, merging. What's merging? Merging means to add two things. To add two things together, two lists together. Whether we can merge two lists together or not. So we have list 1, and in list 1 we have 1, 2 and 3. We also have a list 2, and in list 2 we have 4 comma 5 comma 6. We merge both of them in list, and here we do list 1 plus list 2, and let's see what will be our output of list. See, 1 2 3 4 5 6. It means merging of two lists with each other in list data type is also possible. Next one is conversion. We can convert any string, tuple or set in list. Okay, but we can't convert in dictionary in list. There is a separate method or something. I hope you understood. Okay, so how? Let's first try with a string. Suppose we have a string as Rashmika, and then we do printing, and here we use the conversion the method, I mean the list function, and in which, yeah, let's see what will be the output. See, our string Rashmika has converted into the list. Okay, let's try with the tuple. Suppose we have a tuple. A tuple is created with this round braces 2 4 5 sam, or we can store like 3.9. Okay, then again we are printing it. We are printing this tuple inside the list function, whether it will convert or not. See, you will think that both are same, but not. Here it is in round braces and here it is in not in round braces. Okay, these are square braces. So in square braces we only have lists, not tuples. So tuple is converted into list. Next one we'll try on set. Set is created with curly braces, and in set there is no proper order. So after converting it into list, we can't do indexing because there is no proper order. That's why set is not a sequence data type. Tuple is a sequence data type because in tuple we can do indexing. There is no issue because in tuple everything is arranged in ordered manner in a particular order, but in set it's not. That's why we can't do. 6. Okay, let's convert it. List function, and inside list function we have used set. See, it has converted. The curly braces has been changed to the square braces. So that's the conversion operation of list. Another one is conversion is shallow copying. Shallow copying, and shallow copying is also called as aliasing. Why it's called as aliasing? See, shallow copying means if we'll give the reference of one list to another, then the other list will also point toward the data items of the first list of the assigned list in the memory view. Okay, means assigning of one list to another in memory will reference the data items of the assigned list. Assigning of one list to another in memory will reference the data items of the assigned list. It means the list of which we'll assign the first list in memory will reference the data items of the assigned list. Let's try. Suppose we have a list, and in list we have some these data items, and here we have our list 1, and we have assigned a list with list 1, and now we want to print both of them like list as well as list 1. Both are same. Okay, fine. I hope you know about the is operator. Is basically the identity operator which tells whether both of the objects are same in the memory or not, referencing to the same data point in the memory or not, memory location. See, it's giving us true. It means both of these lists are referencing to the same memory location in data. Okay, And we can understand it through, let's suppose we change list 1. List 1's second index means 3 with 5. And now we'll again print both of the lists so that you can understand it well. See, 1, 2 and 5, 1, 2 and 5. Because why? Because the memory locations are same. Let's understand deep copying. In deep copying, the references are differ. Both of these are stored on separate memory locations, not on the same memory location. So deep copying, or what's called cloning. If you have studied about the SQL, then in SQL we have aliases. Aliases are nothing, just the another name. Okay, if we have a big name, then for calling it short, we make it as an alias. Like in our day-to-day life also, if a particular person have a big name, then we make it short for calling them for less complexity. So same applies in Python. Deep copying or cloning, how we do it? Suppose we have list, okay, and we have list 1 also. List 1 is blank, but with this blank list, if we'll add a list, then now list is pointing toward these data items and list 1 is pointing towards the blank list. Okay, in memory both are pointed toward different memory locations. Both are pointing. But now if we have concatenated this list 1 with this list, then in the memory location of list 1, for which list 1 is pointing, list data items will also add. It won't change the list memory location, but the list data items will be added in the list 1 location. So let's print. Let's see what will be the output. See what it is giving. It is giving false because both are pointing toward the different memory locations, not toward the same memory location. That's why it is giving false. But the data items of both are same. Why? Because here null is having no value. That's why. If here it will 1, then 1 will also add with it. But here it's not. So it's our deep copying or cloning. Let's try searching. Searching we can do through membership operators. I hope you know the concept of membership operators. Membership operators are basically in and not in. So if we have a list like 1 comma 2 comma, oh my mistake, 1 comma 2 comma 3 comma 4, and we want to check like 1 in list. For checking membership whether one is present in list or not, it's giving true. It means yeah, list is present. That's why it's giving. And 6 not in list. First we check with in. 6 in list. It's giving false because 6 is not in our list. What if we'll do it with not in? 6 not in list. It's true. Why? Because 6 is in reality. 6 really is not in list. That's why. I hope you understood the concept of membership operators. Searching operation. Now let's move toward searching identity. Identity we have done. Like list is having 1 2 3 4. List 1 also have 1 2 3 and 4. And let's check. List is list 1 false. Okay, both of them are stored on separate memory locations, or both of them are pointing toward separate memory locations. That's why it is giving us false. What if we'll assign list to with list? I think you are reminding the concept, and it's the concept of shallow copying or aliasing. Let's check. See, it's true. I hope you understood it. And also, like now it is giving false. Now it is giving false and true. If I'll add not, then list not is list 1. List isn't pointing toward list 1. It's true. And list is not pointing toward list 2. It's false because here we have assigned list with list 1. So both are pointing toward the same memory location. Okay, one net. It's not is, it's is not. Let's try. Okay, false true, then true false. But you found something. In the list and list 1, we have similar values, but both of them are differ. But it applies in container data types in Python. But if we do it with basic data types like 3 and 3, 3 is stored in both of the variables, and then we have tried A is B. According to our list concept, 3 and 3 both point toward different memory locations. Like A and B both should point toward different memory locations. But it is giving true. It means A and B both are pointing toward same memory location in which 3 is stored. That's why it's giving true. So the if in both of the lists the data items are stored similar, so they don't point toward one memory location. They point toward different ones. But in basic data types, the concept applies. I mean, if the data is same, then for storing memory in Python, it stores on one location and then both of the variables point toward it. Let's try it on strings. See, it's giving true because string is also a basic data type. I hope you understood it. Next one is comparison. Okay. For comparison, let's see. Suppose we have our list 1 and list 1 have 1, 2, 3 and 4, same like before. And list 2. List 2 have 5, 6, 7 and 8. Now we are comparing. In this scenario, each of the element, I mean each of the data item of the same index will be compared with another, and it will work in repeated manner like list 2. List 2 means the first data item of list 2 on the index 0, that's 5. So 5 is greater than 1. Condition satisfied. Condition satisfied. So what it will give? It will result in true, because you can see all of the data items of list 2 are greater than list 1. Okay. What if the starting two are similar? Now it also giving now also it is giving true. Why? Because 5 condition is not satisfied. Then again checked on 6, condition not satisfied. Then again on 3 and 7, condition satisfied because 7 is greater than 3. Okay, what if we do 7 here and 3 here? False, because the similar one doesn't affect. But here it became false. Why? Because 7 is greater than 3. So it didn't check our next condition or next data item like 4 and 8. Because here it became false, so it is stopped. The execution stopped and the result came as false. Because these two are similar. So here is a draw. Here is a false. Condition fails. That's why the execution stops. So it's for comparison. And also if the data item are less in the above one, then also the comparison will be done till the last indexed data item of the list one, of the least data item list. Okay, one by one with elements. It's for comparison. And for empty, what do you mean by empty? Empty means free. Suppose if a list is have nothing in it, so how we do it? Print it's printing nothing. Okay. uh, we do it with for I. uh, no, we'll do it with if list, and then we'll print empty. Let's execute it. It's printing nothing. Why? Because if condition only works when it satisfies, and now because it is nothing, so it all the it's null, so null is treated as false. So if false, so because of this false, the condition is coming as empty. What if we'll give a false here, then it will print. Okay, okay, it's not also working. We can check the emptiness of a list with not operator. So if not list, see, it is printing empty. So through it we can check the emptiness of a string. Here is another way of doing it. We can do it with converting it into bool. You know bool uh, bool data type gives true and false values. Printing false, same as. So we have covered um all the basic list operations in this video. Emptiness 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All 10. Now we'll meet in the next video with our built-in built-in functions of lists. Till then, bye bye.